Hello everyone, welcome to the class. Now in this video, I will be covering section 3.1, the derivatives of polynomials and exponential functions. In the earlier chapter, we saw the definition for the limit, and then how limit definition can be applied to find the derivative of a function. And then we interpreted the derivative as rate of change or instantaneous velocity and so on. We did lots about the limits and how it can be applied to finding the derivative of the function. Now, in this chapter, we are not going to be using those definitions as much, but we will be giving rules. We will be finding the rules of the derivatives of different functions like polynomials, exponential and logarithmic and so on, trigonometric functions, inverse trigonometric functions and so on. Then we will apply those rules to the problems. So first, derivative of a constant. We know that derivative also means slope. So when you say a constant, it is a constant function. So it will look like a horizontal line. For a horizontal line, the slope is 0. We know that derivative also means a slope. So d by dx of c, the constant, equal to 0. That is the first rule to memorize. And what is the derivative of just x to the exponent 1? So when you say derivative of this, d by dx means derivative of. That's the way you say derivative of a constant. Derivative of c with respect to the variable x. That's the way you interpret. That's the way you read the d by dx. Same way, derivative of x equal to 1, because if you consider this as a function, f of x equal to x or y equal to x, this one would mean y equal to x. But if you consider the line, what is the slope of this line? If you compare it with mx plus b, then you get m equal to 1 here. That is the slope of the line. So derivative of x equal to 1. So what is the power rule? The first rule. If n is a positive integer means it's all whole numbers starting from 1, 2, 3, 4, etc. Then d by dx of x to the exponent n would be n x to the power n minus 1. In other words, if you do d by dx of x to some exponent, it would be that exponent times x to the power, that exponent minus 1. So let's use, in fact, we will be extending this idea of power rule to any real number. For now, we will stick with the positive integer. If f of x equal to x to the power 6, then f derivative of f of x. So the derivative can be written as f prime x. The derivative of f of x is the exponent 6, x to the power exponent minus 1. So 6x to the power 5. Y equal to x to the power 1000. What is y prime, or the derivative of y? So it is the exponent x to the power exponent minus 1. So it is 1000 x to the power 999. If y equal to t to the power 4, then dy by dt. Keep in mind, so we have expressed the same derivative in different forms. One given as a function of x, given as y, given y as a function of t. Then when the function is a function of t, then it makes sense to write dy by dt, or derivative of y with respect to t. So which will be exponent times t to the power exponent minus 1, or it is 4t cube. D by dr of r cube, or derivative of r cube, with respect to r, because the function is here treated as y equal to r cube, which is a function of r. So it is exponent times exponent, r times exponent minus 1, so 3r squared. So the important thing that you notice is that how differently each function is represented here. Okay. And what is d by dx of 1 over x, the reciprocal of x? So far we know only, so we can also extend the power rule to negative exponents, so negative integers. So power rule for negative integers and rationals is also same as d by dx of x to the power n, it's n x to the power n minus 1. Here we can assume n to be an integer or rational. These are exponents. Exponents are negative integers or rationals, let's say. So d by dx of 1 over x is d by dx of derivative of x to the negative 1. So you can write 1 over x as x to the power of negative 1. So in that case, how do you apply the rule? Exponent x to the power exponent minus 1. So negative 1 x to the power negative 2. The other way of writing it is negative 1 over x to the negative 2 can be written as 1 over x to the positive 2. So you can write like that. So derivative of 1 over x is negative 1 over x square. We will be using this often. It is even worthwhile memorizing that as a formula. Now, d by dx of square root of x, can we write that as a rational exponent? You can write square root of x as x to the power of 1/2. So rational exponent. So when you have a rational or negative integer exponent, the same rule applies, power rule applies. So it is the exponent x to the power exponent minus 1. So half x to the power negative 1/2, which is 1/2. If you bring this down, you can write that as x to the power 1/2 below. So which means that it's 2. What is x to the power 1/2? It is square root of x. So derivative of x to the derivative of radical x is 1 over 2 radical x. Again, this can be, these two are often used. So it's worthwhile memorizing them. The power rule, which is a general version here, if n is any real number, then d by dx of x to the power n is n x to the power n minus 1. Then next, let's see different types of functions. The constant multiple of a function. If c is a constant, and f is a differentiable function, then d by dx of c f of x is c times derivative of f of x. What we do is we move the c outside of the derivative. We know that derivative means rate of change. So rate of change of x in this case, the rate of change of y with respect to x. The constant does not get changed no matter what the value of x or y are, right? So that's why constant is unaffected by this derivative, so that constant can be taken outside of the derivative symbol. The sum rule. If f and g are both differentiable, then derivative of f of x plus g of x is derivative of f of x plus derivative of g of x. So the derivative of the sum is sum of the derivatives. The difference rule. If f and g are both differentiable, then d by dx of f of x minus g of x is derivative of f of x minus derivative of g of x. It looks as if we are distributing the derivative. That is, derivative of the difference of two functions is same as difference of the two derivatives. So using this, we can solve these problems. Derivative of x to the 8 plus 12x to the power 5 minus 4x to the power 4. So we can apply the derivative to each expression using the sum function here. So it is derivative of the first plus derivative of the second plus derivative of the third. The derivative of the first is 8x to the power 7. Then the derivative of the second here, 12 is a constant which can be taken out. You can take the derivative of x to the power 5. You can take the derivative of x to the power 5, which means it is exponent times x to the power exponent minus 1, which is 4. Then here negative 4 is a constant which can be pulled out of the derivative, negative 4. Then apply the derivative of x to the power 4, which would be 4 x to the power 4 minus 1. So the final answer to this one would be 8x to the power 7 plus 60x to the power 4 minus 16x cube. Then another formula, derivative of natural exponential function, where a is a constant. Derivative of constant to the variable x. So all along in the power rule, we had the base as a variable. So if you notice the gender version of this, here, base is a variable. A is a variable. Base is a variable. And n is an exponent, and that is a real number. Exponent is a number, right? Base is a variable, exponent is a number for the power rule. But here, base is a number, and exponent is a variable. The derivative of a to the x is a to the x, ln a. Okay, we will be using this later on in logarithmic derivatives too. So for now, memorize this formula. Derivative of a to the x is a to the x ln a, where a is the base, which is a number, exponent is a variable. Earlier in power rule, what you need to understand is derivative of a variable to an exponent. Exponent is a number, variable is the base, then it will be exponent x to the power n minus 1. Clear? You notice that caution here. Caution is that a derivative of a to the x, oftentimes it is not x a to the power x minus 1, because the base is here a number, exponent is a variable. So you have to use only this rule here. So next, let's take an example. Find the points on the curve y equal to x to the power 4 minus 6x squared plus 4, where the tangent line is horizontal. So we know that slope of the tangent line is nothing but the derivative at a point, right? So the question is asking us to find the points which are, it could be more than one, xy's on the curve where the tangent line is horizontal. So if the tangent is horizontal, what can you say about the slope? Yes, it is equal to 0. The slope of a horizontal tangent is 0. That means the derivative of the horizontal tangent, derivative of the horizontal tangent would be equal to 0. Slope means the derivative, we know that. So let's take this y given in the problem, x to the power 4 minus 6x squared plus 4, and they'll find the dy by dx there, which is 4x cubed minus, I'm taking the derivative of each term, so it is 12x, derivative of x squared is 2x, then derivative of 4, derivative of a constant is 0. They're going to set this derivative to 0, slope equal to 0. So we have 4x cubed minus 12x equal to 0. So if you take the 4x out, means x squared minus 3 equal to 0. This gives either 4x equal to 0 or x squared minus 3 equal to 0. So if you divide both sides by 4, this will become x equal to 0 or x squared equal to 3, which means if you take the square root on both sides, you will get plus and minus square root of 3. So x would be plus or minus square root of 3. So x equal to 0 and x equal to plus or minus square root of 3. The question is asking us to find the points. Points are usually x comma y. If you know the x, we can find the value of y by plugging in these values into the original y, right? So substitute x equal to 0 and x equal to plus or minus root of 3 into y. So y is given to be x to the power 4 minus 6x squared plus 4. If we plug in 0 for x equal to 0, I get y equal to 0 power 4 minus 60 squared plus 4, which means it's just 4. So if I combine the pair x comma y, it is first point where the horizontal tangent occurs is 0, 4. So let's plug in x equal to root of 3. Both for x equal to root of 3 and negative root of 3, we are going to get the same y because the given equation is the given equation is an even degree polynomial. So it has to be the same. So y equal to, so root 3 to the power 4 minus 6 root 3 square plus 4. We are plugging in this value into x, correct? Okay, this will be, what is root 3 to the power 4, which is root 3 multiplied by 4 times, which will be 3 times 3, 9, minus 6 times 3 plus 4. So it is 9 plus 4, 13 minus 18. 13 minus 18 would be minus 5. So if we pair them, the point would be, in this case, root 3, negative 5. Same way, when x equal to negative root of 3, y would be equal to negative root of 3 to the power 4 minus 6, negative root of 3 the whole square plus 4. It should be again 9 minus 6 times 3 plus 4, which is again going to be negative 5. So the corresponding point is, what is the corresponding point? It is ordered per x comma y. X is negative root of 3. What is y? Negative 5. So you will conclude that the points where the tangent is horizontal on the curve are first point 0, 4, root 3 plus or minus root of 3, negative 5. There are 3 points. You can combine them like that. The key step in the problem is to set the derivative to 0. How do you know why it should be set to 0? Because the tangent line is given to be horizontal. All right, let's see a couple of questions. There are some problems that are already done in the external video for this chapter. But in this concept video, all these videos are called concept videos. This concept videos, I will do few problems from the exercise. And let's try this number 21 or number 17. Both looks kind of similar approach. So we will try them. Let's try number 21. Let me do that right below number 21. So you notice that some of the problems in this additional suggested problems, say there are star symbol and there is a PT symbol. If that says PT, that means it's a practice test problem as well. So it's a good idea to practice all these problems, so get to know the rules memorized. Okay, y equal to, so we are finding the derivative. We call it dy by dx, which is derivative of the first term plus derivative of the second term. Cube root of x. So how do you write cube root of x as, this is the index, and we know that if it is the index, then it should be written as a reciprocal. In the exponent form, the rational exponent form, it becomes x to the power 1/3. So it makes sense to write that way because power rule always applies to x to the variable as the base. Exponent should be a number. We want to make it look like a number so that we can apply the power rule. This 3 is a constant which can go out of the derivative symbol. Derivative of e to the x is e to the x. So did we mention that here? So you know that derivative of a to the x is a to the x ln a. Derivative of e to the x is e to the x ln e. What is ln e? Ln e is equal to 1. So it is just e to the x. So derivative of e to the x is e to the x. So it's one other formula which you can memorize. So if I have, that can be included here where it says log derivative of So along with this definition, derivative of a to the x, which is a to the x ln a, we can make a note that derivative of e to the x is a special case of this, where a is e, so it becomes e to the x ln e, but ln e is equal to 1. So derivative of e to the x is e to the x, which we will be using quite often in our problems. So it is 3, derivative of e to the x is e to the x. Then for the second part, you can write this as d by dx of 4 times x to the 1/3 below, x to the 1/3 below, which can be written as x to the negative 1/3 up. So it is 3 e to the x. 4 is a constant which can come out of the derivative. Then it is x to the variable to an exponent. Exponent is some number. So it is exponent, x to the power exponent minus 1. So it is 3e to the x minus 4 by 3 x to the power negative 1/3 minus 1, that will be negative 4 over 3. So if you do this, now multiply by 3, that will be negative 1, negative 3 over 3. So negative 4 over 3. So dy by dx for this problem is 3e to the x minus 4 over 3x to the negative 3. We can also write this without the negative exponent, just 3e to the x minus 4 by 3, 1 over x to the 4 by 3. That is one way to write. Or you can also write 3e to the x minus 4 by 3, 1 over cube root of x to the power 4. So these are all several ways of writing it. You may want to write, this is more appropriate because we are writing the exponent in the positive form. Okay. So this is one of the practice exam questions. Let's try another one. So let's try this, finding the equation. Find an equation of the tangent line to the curve at the given point. Let's try number 38. Y equal to 2e to the x plus x at the point 0, 2. The equation of the tangent is a very common question, even in chapter 2 and even in chapter 3 now. So in chapter 2, when we did equation of the tangents, when we wanted the slope of the tangent line, we actually had to do either definition 1 or definition 2 or the limit definition, right? So in this one, as we have lots of rules for all kinds of functions, in this particular section, we are looking at polynomials and exponential functions only. You will be doing a lot more in the upcoming sections. So each time you will have a technique to find out the slope or the derivative for a particular function. So use the slope and then use the point through which it passes. Then we know the point and the slope. Then all we need to write down is the equation in slope intercept form. So which will become easy. So first thing is to find out the slope of the tangent line. So we will first find out dy by dx. M is a number which is a slope at a specific value. Here we are going to plug in x equal to 0. So the point given is 0, 2. So let's do first dy by dx, so which is to find the slope of the tangent. Find the slope of the tangent. You find dy by dx, which is d by dx of 2e to the x plus x. So which is derivative of 2e to the x. 2 is a constant. Derivative of e to the x is e to the x. Derivative of x. What is derivative of x? We already said that in the beginning. X to the power 1. So 1 x to the power 0. So it is just 1. So it is 1. Also, you can look at this as a line passing through the origin, y equal to x, and the slope of that line is equal to 1. So now the slope of the tangent line is the derivative at a specific point. Here the specific point is x equal to 0. So x equal to 0. So we will substitute that into this expression here at x equal to 0. So it is 2e to the 0 plus 1. E to the 0 is 1. So 2 times 1 plus 1, which is equal to 3. So the slope equal to 3, slope of the tangent line. So equation, so this is the first step. The second step is to find out the equation of this tangent. Equation of the tangent line at 0, 2, is what? Y minus y1 equal to m times m equal to 3. Slope is 3, x minus x1. It's y minus 2 equal to 3x. So if you move the 2 to the other side, you get y equal to 3x plus 2. That is the equation of the tangent line. Let's try another problem, which is a word problem here, number 53. The equation of motion of a particle is s equal to t cube minus 3t, where s is in meters and t is in seconds. Find A, the velocity and acceleration as functions of t, then the acceleration after 2 seconds, the acceleration when the velocity is 0. So there are 3 parts to this problem. So let's do them one by one. So remember that velocity is the first derivative. Velocity is the first derivative. Which is s prime, and acceleration is the second derivative, which is s double prime, because the function here is s. Function s is a function of t. The distance is in terms of t. S is the distance function and t is the time. The s is measured in meters, t is measured in seconds. So that is the first part. The second part is asking us to find out the acceleration after 2 seconds. So we have to substitute time t equal to 2 into the acceleration and find out what the acceleration is. The third part, we have to set the velocity to 0 and find out the time that makes the velocity 0, which means that the particle is coming to rest. So once you do that, t equal to 0, when velocity equal to 0, find t, then find out the acceleration corresponding to that time, which makes the velocity 0. So we'll do one by one. The distance, s is the distance. T measured in meters. T is the time measured in seconds. So we can also write this as s as a function of t. S in terms of t. What is the distance covered at a particular time t? So let's start with the first one. The first part is asking us to find the velocity and the acceleration. Velocity and acceleration at any time t. So what is the velocity? Is s prime t. So you're going to take the derivative of t cube minus 3t. Derivative of 3 cube minus 3t. This is derivative of 3 cube, t cube, which is 3t square, right? Exponent times t, exponent minus 1. Derivative of 3t, what is that? Derivative, it is just 3, right? So velocity is 3t square minus 3. You can also write that as 3 times t square minus 1 meters per second. Velocity is rate of change, which is change in position over change in time, or change in distance over change in time. Displacement over time. So displacement is measured in meters, time is measured in seconds. So it's meters per second. So the first part is this, that is the velocity. What is the acceleration? Acceleration is the second derivative, which is the derivative of derivative. Derivative of the first derivative. So you can consider that as the derivative of d by dt are the first derivative, s prime t, which is the derivative of what is s prime t that we have found out from the previous step, which is 3t squared minus 3. So if you do the derivative of each one of these terms, that will become 3 times derivative of t squared, which is 2t. So it will be 6t minus derivative of 3, which is 0. So it is 6t meters per second square. Because on the numerator, it is, what is the acceleration? Change in velocity over time. Change in velocity will be already meters per second, and then over time will be again second. So meters per second over second, that will be meters per second square. So acceleration for this one is going to be 60 meters per second square. So both these values are in terms of t. Now let's get to the second part of the problem, which is asking the acceleration at a particular time. What is the acceleration? The question is asking us to find the acceleration after 2 seconds. So in other words, we are going to find out a for acceleration at 2, or we are going to find out s double prime t, the second derivative, at t equal to 2, or after t equal to 2 seconds. What is the acceleration in terms of t from part A? So it is 6t. 6t when t equal to 2. That will be 12 meters, 6 times 2, that is 12 meters per second square. That is acceleration after 2 seconds. Now what is part C? Acceleration, find the acceleration when the velocity is 0. So find the acceleration when the velocity is 0. So we want to find out the acceleration at a specific time. What is that specific time? When the velocity is 0. That is, when s prime t equal to 0, right? Velocity is 0. So we will set the velocity to 0 first. S prime t equal to 0. That will make the velocity equal to 0. What is the velocity from what we found out? It is 3 times t square minus 1. So 3 times t square minus 1 equal to 0. If you divide both sides by 3, you get t square minus 1 equal to 0, which means t equal to plus or minus 1. But time is always positive, so t has to be equal to 1 second. So after 1 second, the velocity becomes 0, or the particle stops. So that means we are asked to find out the acceleration at a specific time. So acceleration at t equal to 1 second is what we need to find out, which we write that as a at 1. So what is a from what we found out in this part A? Which is 6t. So 6t evaluated at t equal to 1. So which will be just 6 times 1, just 6 meters per second square. So remember to write velocity in terms of meter per second, acceleration as meters per second square. So try all these suggested problems from the exercise as much as you can. Many of them are in the homework already. And there are some problems that are done in this concept video. There are some more that you will see them in the practice exam videos as well. So in this, if you notice this practice number 59, practice test 59, find the point on the curve where the tangent is horizontal. We have done a similar problem for that. Find the point where the tangent is horizontal. We did a similar problem here in this example. Take that as a reference and do the problem 59 similarly. Hope this video helps. I will see you guys for my next video on section 3.2.